Hello everyone, today in this video we are going to see what happens if we apply an alternating voltage to a resistor circuit. So after this video you should be able to derive the expression of voltage and current for a resistor circuit, and you should be able to draw Phasor diagram and the graph for resistor circuit. Phasor diagram is a diagram in which we represent current and voltage as a vector with some angle between them. So suppose the voltage is given by E is equal to E naught sin omega t, and suppose the current is I is equal to I naught sin omega t plus phi. So this phi is the phase angle between them. So I'll show you the example. Out here voltage and current is starting from the same point and ending at the same point. That means there is no phase difference. So out here the phase difference is 0, this phi is 0, but out here you can see current and voltage are starting from different points, so there is a difference of phase between them. So we can say there is a phase difference and phi is not 0 for this case. Now we'll see how to draw a phasor diagram. So our alternating voltage is given by E is equal to E naught sin omega t. We will draw a coordinate system, and E naught is the peak value, and this voltage keeps on changing with this angle. Now out here you can see I'm representing the peak value with a vector, and this side we have the voltage. Right now the value of voltage is this much. Now when I increase the angle, the value of voltage should increase. Now in next case you can see, so in AC with time the voltage changes. So out here now you can see the angle is more and the value of voltage is more. So when it goes this side it will start decreasing, when it goes down the value becomes negative. So you can see for different angle we have different value of voltage. Now I'll just draw one vector to represent E naught, and the angle is omega t. Now I have to draw the vector for current. Now current is given by I is equal to I naught sin omega t, and out here you can see the angle of current is greater than the angle of voltage, because for voltage is omega t and for current it is omega t plus phi. And suppose our voltage is greater than the current, so I'll draw one vector out here. Now you can see the length is little shorter because I'm considering the magnitude of current is less than the magnitude of voltage, and the current is phi angle ahead of voltage, so this angle is phi, and the angle subtended by I is omega t plus phi, so this angle is omega t plus phi, and this is the value of current and this is the value of voltage. Now this is the phasor diagram representing voltage and current. So now we'll derive the expression for AC through resistor. Now we are considering a circuit with resistor and we are applying the AC voltage, and AC voltage is given by E is equal to E naught sin omega t, and in some books they may use V is equal to V naught sin omega t, or V is equal to Vm, or V naught or Vm is the peak value. Please don't get confused with this. Let I be the current at any time t, that time we can use Ohm's law, voltage is equal to IR. Now I can write I is equal to E by R from here. Now I'll put the value of E, so it's E naught sin omega t by R, and I'm separating E naught by R, and for E naught by R I'm writing I0, and I0 means peak value of the current. Now after putting the value of I naught you will get I is equal to I naught sin omega t. Now this is the expression for voltage and this is the expression for current, and you can see they have the same angle, so that means no phase difference. So we can say when current is 0 the voltage also becomes 0, and when current is maximum voltage is also maximum. There is no phase angle between them, and so they increases and they decreases at the same time. So you can say the phase angle between voltage and current in resistor circuit is 0. Out here you can see E naught by R is I naught. That means if you divide E naught by R, then only the value will become equal to I naught. That means E naught is greater than I naught. Now in phasor diagram, the E naught will be longer and I naught will be shorter, because the magnitude of current is less than the magnitude of voltage, and there is no phase angle. That means the angle subtended by E naught and I naught is omega t. So if you consider this equation that we have taken before, E is equal to E naught sin omega t and I is equal to I naught sin omega t plus phi. So in resistor circuit, phi will be 0 and the angle between I naught and E naught will be 0. So this is the graph between voltage and current for AC through resistor, and you can see voltage and current, they are in same phase. They are starting at same point, they are starting at the same time, and they are ending at the same time. So there is no phase difference between voltage and current. So this is the end of the video. Don't forget to like the video and subscribe the channel. Thank you.